Hello. Today I made, actually yesterday, I made the progress, small but very significant because I couldn't start these motors back again as it was in the first circuit. This was the version 1, very extremely brutal circuit. This one is having 1 or 2 pins burned on it, and as you can hear it, and as you can see it here, is stopping at a point. Let me give it the lowest possible. You see, it's not really continuous. One is getting on the final lead here, on the fourth lead, is staying a little bit, then is starting from 1, 2, 3, 4, then staying a little bit and so on. Because I have only these two chips, these two 4017 chips, and one of pin number 2 on it is burned, so I had to put from 3, 4, 5, and 6, and stop and reset from on the 7th. You have a reset, master reset here, and you have to link it to the final pin that you want to stop and reset back to 0, pretty much. This was the original one. It started on 0, 1, 2, 3, and on 4th pin was resetting to go back to 0, pretty much. And then what we are seeing here is the upgrade. This circuit is having its own story, its own history of trying and error. So these resistors that are more symbolic here, because I was the big mistake that I did before, and it wasn't working at all, was including bigger resistor values. I put 10 kilo ohms in the first time. Nothing worked. Only the logic, the LEDs were showing me that it's working, but the current didn't reach the motors, both of them. Actually, this guy was extremely sensitive and helped me debug this problem extraordinarily. This guy that is new, this is scrapped motor. This is a scrap motor from a printer or something. But this guy here is absolutely brand new, and it helped me realize how weak this circuit is, but it's functional. This is what I'm presenting here. This circuit, it is very functional. And then I switched. I get the bright idea to get lower the resistance, and I didn't leave those 10K, and I put 1K on every base of these transistors. So I replaced everything that I have there. But after playing and thinking about it, and actually this guy helped me, the first version that is extremely brutal, it worked without any kind of resistance on the bases of these transistors. It worked from the beginning. I was extremely lucky to, in a sense, to test this version and not put resistors at all. I was stupid, but this stupidity actually saved this circuit to actually make it work. So now I remember that stupidity that I made before, and now I've inserted, with that knowledge from there, I inserted only 10 ohm resistors on each of the bases. They are more symbolic because these transistors can be driven a bit more brutal without any kind of resistors on their bases to deliver absolutely the maximum power through them, the maximum current through the coils of the motor. Remember, this H bridge is a half of the motor, is driving only one coil. These two wires are representing one coil, and this half bridge is driving the other half of the motor, the other coil, the coil number 2 and coil number 1. So pretty much this is it about what I did, what I improved. This is the improvement of the circuit, pretty much. All right, right now I will show you how it's actually working, because it's having some problems. This circuit is by far not the best circuit to put it and to drive your motors. It's more like a test circuit to see if the motors are working. And this circuit will not drive these motors to their maximum potential. I'm not sure if it's 50-50, if it's only 50% or 25%. Because you will see in a second what I mean by that. If I'm putting more voltage into the circuit, it will increase the amperage, and these transistors will get extremely hot and possibly being destroyed if I'm increasing the voltage, the power, pretty much. But at 5 volts as it is right now, it's pretty stable, which this is the cause that I'm making this movie. This is a digital thermometer, and let's probe. Let's see. It's running for some while right now. So this transistor is about 50 Celsius. It's not in Fahrenheit. So this is 47. This is another one here. Also 47, 48, 49. Let's say it's 49. I know that one is a bit more weaker. This is 45. And this also 45. So under 50. I kind of get a kind of a 50 at some point in time when I was measuring, and I was remembering 50. But it's a bit below 50, which is good. Right. The speed, because it's running like tuck, it's creating all those 4 impulses and then stopping, and another 4 impulses and stopping, and so on and so on. It's kind of having this weird pattern. You can actually hear it. And here is the minimum, because I changed the capacitor here. I put that a smaller one. It was 10 microfarads. Now it's 1 microfarad. This is another, here, this guy here. This guy is actually dictating the speed and the minimum and the maximum. It was 10 microfarads, and I've inserted 1 microfarad. So let's push it to the maximum. And now I'm somewhere here. Somewhere here it's maximum. and I put this metal sheet here to actually make it hear it, to leave you hear it, and you can hear it just fine. So this is super fast frequency here, and this is very extremely close to how it was behaving in the first version that wasn't having any kind of protection from those diodes and the bridge rectifiers. So this is the first motor that is extremely sensible. It helped me a lot. And let's test the second one. 2 ports here that I'm inserting. So I'll take out this guy and insert this other guy, which is brand new, and it's giving me also, yeah, it's fluctuating. Like I say, it's 300 and 600 milliamps, and this is a bit. Let's see. This is the minimum, and you can hear it. It is extremely powerful when it's the lowest speed. Very powerful. I cannot hold it with my fingers, but it can be held because this is not its voltage. Normal or nominal voltage that is working. It needs a bit more higher voltage. It works with higher voltage than 5 volts that I'm having right now. So let's increase the speed. And as you could see, it's working immediately after I plug it in, and immediately after I plug it in, this one as well. So this circuit is quite good from this point of view. I make it to be this good. I had a ton of problems to resolve. Like I said, it's having a lot of history, this circuit. This is the maximum. So this is pretty much the maximum speed it can run with this driver circuit that I have here at 5 volts. And when it's faster, actually it's more stable. The 300 milliamps is more stable. It's not fluctuating between 600 and 300. It's a bit more stable right now. And the experiment, and let's check the temperature again. This is the ambient temperature that I have in the room with this guy in the air, 25 degrees, like a book, like in the book. So let's test these transistors that I know they are getting very hot. This is 48.9. It was a little bit of 49. Okay. Let's test the other one. 47. Pretty much like the other one. And this is more demanding motor. It is requiring more. 47. It's requiring a bit more power than the other one. The scrapped one is more sensitive. This is 45-ish. As you can see, it's pretty stable on the temperature. This is the biggest element that I'm considering, the safe element, how to drive these motors. Before I was a bit more stupid by inserting this very high voltage motor that is drawing a lot of power to be operated, unfortunately, and it damaged. Because of that, I got all these problems. But running everything at 5 volts is absolutely fine with this circuit. So if I'm pushing the voltage too high, it will destabilize all this circuit, and it will run hot the transistors, and it's not good. So this is very limited circuit that I have here, only for 5 volts, not more than that. For small and medium, let's say these are medium motors in size. Now I've increased the voltage to 6 volts there. This is kind of fluctuating a little bit, it shouldn't. This is maximum. The speed is a bit more faster right now at higher voltage. But let's say it's working right now, but I had a limit where it was resonating or something, and it stopped working. Probably it will. Let's plug it back again and let's see if. No, it's stable right now. It's stable for some reason, but it wasn't stable a lot of times. And the other motor, this guy doesn't want to start at all. So I'm resetting by taking out, restarting. I'm restarting the circuit by taking the power and putting the power again. And this is probably a bit more faster. This is the fastest and save. Yeah, somewhere there. As you can see, the power increased 6 volts and almost 500 milliamps. So right now we will have a bit more heat on the transistors. Remember, all of these transistors are NPN. There is no PNP transistor here at all. So, right, 25 is ambient temperature that I have right now at this point. 60. So here is, can you see it? So it's, hey, come on, 60. Yes. And this guy here, 59, also 60-ish. It's like 15 degrees almost, the difference, with 1 volt. With 1 volt is 15 degrees higher in temperature. Right now, I will do the stupid thing, and I will raise it to, but not very much, to 10 volts. So let's do it to 10 volts. This is the, yeah, 9.9, 10. Yeah, the speed is a bit more higher. It's a better performance right now. Yeah, the speed is definitely higher. But I can smell the I'm closing the power supply right now. I'm putting the thermometer very quickly with the power supply closed because I can smell which one. All right, let's try it again. 75 should be higher. Yeah, 80, 86, 90. I think this is the winner. 97, 99. Oh, 100. Okay, I'll stop it because I can. Yeah, definitely, I can smell the hot iron smell. Yeah, I definitely can smell the hot iron. So that's why this circuit is very inefficient. I put it back to 5 volts as he likes it. At this frequency, it was turning fine at 10 volts, but here it is not liking it. So definitely this circuit can be improved with more power more powerful transistors. It is working as it is right now. It's working absolutely fine. Let's see this. This also got heated up. The voltage regulator that I have here. Yeah, I forget to put the thermometer on it, but it got hot, quite hot actually. But it did its job. It protected the entire circuit here, the logic circuit, and nothing burned. That's very, very extremely important. The driving circuit here, the coil driving here is needing more powerful transistors probably. And these motors can run at a bit more higher voltage than right now. Right now they are running extremely safe with this circuit that I have here, which is quite good in my opinion, but is good for testing and to run the motors underpowered, not at their 100% potential. So right now they are running like probably 25% or 50% probably. I'm not sure exactly. I didn't reach too higher voltages. I didn't increase to too much higher voltages because these guys were giving up. The conclusion of this circuit: the circuit is good, the circuit is functioning, the circuit is doing its job, is well protected at this point as it is, even with those 10 ohms resistors that are more symbolic there. Those 10 ohms they really don't matter. If something will have to be burned, will burn with or without that 10 ohms resistors. That is very symbolic there. They are influencing the protection a little bit, a tiny bit. But like I said, the circuit is functioning, is good, only for 5 volts, not for higher voltage, because it will increase the power and the temperature on the transistors, on this driving circuit that I have here. And inevitably it will destroy one of them and the circuit will not work anymore, and end of story pretty much. So that's the conclusion for what I did already right here. And what I'm showing you is that is functioning even with NPNs, not at the highest percentage, not at the maximum rendement that these motors can be driven, but at a way more lower rendement than they can be run at. What is important is that this circuit is functional and is good to a point for testing purposes, and why not for running these motors, because you can actually do some job with them. As underrun as they are right now with this circuit that we have here, they can be used practically. And this is not that powerful, this motor, this scrapped motor, but it's more speedy than this one. This one is very powerful actually. At lower speeds is very, very powerful, and I like it. I mean, more powerful than this one. I didn't test its actual to put some kilograms and to see him lift those kilograms. I didn't make that test yet because I don't have a proper driving circuit. But that's I hope I can resolve this issue. Make some noise. Like that. So yes, pretty much I believe this is it about the circuit. I hope I didn't forget anything important. And thank you very much for watching. And yeah, leave a like. And see you later, alligator. Bye bye.